Okay guys, in this video we're going to be basically confirming that two functions are indeed inverses of each other. And the way we're going to do this is we're going to find f of g of x given two functions f and g. And we're also going to find g of f of x, and we want to determine whether each pair of functions f and g are inverses. So how are we going to do this? Well, let's go ahead and just kind of remind ourselves what we mean by inverse. Inverse, of course, just means opposite. So when we say opposite functions, basically we're looking at two functions that do the exact opposite things. I could think of some things like, say, multiplication and division that are already opposites of each other. When we look at this, say, example here where f of x is 4 times whatever I give you as an input, we'll look at g of x. It kind of says, well, now give me whatever that number is and I'll divide it by 4. And so the weird thing is kind of one undoes the other one. If I take a number divided by 4 and then I take that number and I multiply it by 4, these two kind of things kind of undo one another. So really what we're talking about with inverse functions is, I guess more formally, that we're plugging an x value into a function f. And we get some output, some y value here. Okay, so same as y. But basically what I want to have is a function that, if I ever needed to, would undo what I just did, kind of like these would undo each other here. And so what happens is we define a new function, and this right here, this is so important to me. You guys, we call this f inverse. Okay? So f inverse is how we would pronounce something like this, just like I would say this is g inverse of something, like g inverse of x. We say that this f inverse rule, what it does is it takes this output here, this f of x value, which was in the range of the original, and we plug it into this inverse function. So really the range values of the original, okay, are the inputs for our inverse function. So the domain values of our inverse function, and what it does is it sends it back over to x. So the way I would write this more formally is, if I were to take f inverse, okay, which is this function that undoes my original function f, and if I were to take all the y values of the original, the definition of an inverse function is, if I were to take those, it would send it back to the original x value. And so you can see that our range values of the original become the input or domain values of our inverse function, and the output values over here, these original domain values were the input, input values of the original, or the range values of this inverse function. Basically what I want you to see is that when you plug in y, you get back to x. And so to confirm that two things are inverses of each other, what we really do is we just take one and plug it into the other one, and what we're checking to see is, do you get back to the original input? So one way I can do this is just to make a table of values, and that's what I'm going to ask us to do first. Even though they've asked us to write f of g of x, g of f of x, we're going to write x, and I'm going to write f of x here. And so what I'm going to do is I'm going to just plug in some values like 1, 2, 3. And so to prove that these are inverses, what we'll do is we'll take 1, 2, and 3, and we'll plug it into f of x. I get 4 times 1, 4 times 2, 4 times 3. And then so what I'm going to do now is I'm going to formulate another table here. And in this table, what we're going to do is we're going to write g of x. And so to prove that these are inverses, okay, remember what I should be able to do is take these outputs here, okay, and make them the inputs of my inverse function. What I should get back to is my original input value. So to check this out, if I plug 4 into my g of x here, g of 4, I would get 4 divided by 4, which is, you guessed it, 1. And also, if I were to plug in 8, g of 8 is 8 divided by 4 is 2. And g of 12, which is 12 divided by 4, is 3. What you can see is that all of these values that were the outputs of the original become the inputs of the inverse function. This is f of x, not g of x here, sorry. But also, all the inputs of the original become the outputs of the inverse. And so our domains and ranges really switch. Remember, domain and range just flat out switch. So if that's the case, we would have to test every x value in the first function, get all infinitely many y values, and then take all infinitely many of those, so 2 times as long as eternity, and plug them in and get all these outputs here. Or what we could do is more formally just say, we're going to plug all of the y values of this function into the other one, and what we're checking to see is, do we get back to the original, which is just x, like this right here. So what we're going to do is this, f of f inverse, okay, should send me back to x. In other words, plug the y's into this one here, you get back to the original x values for all y values, okay? And we could also do f of f inverse of x. And what we should do is say, plug all the y values of this into f, I should get back to x. And so that being said, what we could look at is inverse functions kind of like undo one another, which is the whole idea. They invert one another. So what we're going to do is this. We're going to find f of g of x. I suppose I'll follow the directions now. And we'll find g of f of x. This will only take a second here. But we're going to plug g of x into f. So if f is 4 times my input and my g of x, well, let's just go ahead and plug in x over 4 here. What you're going to see happen is this. I get x. And also down here, g of f of x. Well, g of x is x over 4, so we're going to take f of x and divide it by 4. And so f of x being 4 times x, my 4's cancel out, and I just get left with x. So the reason why this is profound is because you just plugged all infinitely many y values of 1 into the other one, and you got back to x every single time. So what we're checking for with inverses is, they're inverses if I plug one into the other one and I get x. So let's check out number 4 here, just really quickly. This time, we don't have to go through a big, long speech. We could just say, let's go find what happens when I plug one into the other one. And so f of g of x, let's see, we're plugging into f here. And so I would get 4 times my input plus 9, where my input this time is g of x. So really weird, but I'm going to plug g of x into this space right here and simplify it. We're going to get our 4's to kick out, so I get left with x minus 9 plus 9. I'm going to leave this in parentheses until I realize that, hey, you know, you don't need them anymore. Now you can drop them. So my 9's cancel out, and fantastically, what we said is that all the outputs go back to the input here when you plug this into the other one, which means they're inverses. And we say g of f of x. Well, okay, so g of x, we're going to take g of f of x, and everywhere I see an x, which is right there, input minus 9 over 4, we're going to input our f of x. And so I guess I'm taking my time on this one here. I would plug f of x in here. We say 4x plus 9. So I can drop my parentheses here. I see that my positive and negative 9's here, they cancel, and I get left with 4x over 4, which in that case, our 4's cancel, and I get back to x. So really quickly here, before we piece out of this, the whole gist of it is one function should undo the other one. And another thing I want to mention to you is, if you plug a function into another one and you get back to x, it's not worth your time checking the other one because it's definitely going to work there as well. Cheers.